What is up? Today we are going to start in C++ with SFML, and we're going to show off two tactics for game making, two helpful tips to, important things, I guess. Maybe it's important for your game, maybe it's not. It's important for mine. The first of these is going to be interactable objects. This is really just a basic collision detection function, which can be super important for many people. And then the second is the ability to switch between quote-unquote scenes, move back and forth between rooms. This is not important for everyone, of course, but it would be real nice for a couple games, maybe a tile, map, dungeon sort of thing. Or this, I'm switching between two halves of a room because without it the room would be very long and I'd have to make my screen a weird size. So let's get into the code and learn what's up. We're going to start with the room switching because it takes up most of the coding, and then this interactable object feature, well, will just be a few lines that we'll go over. Alright, let's check it out. This is my beautiful, beautiful code, nicely organized for about half of it. Let's dig right in. This first part right here, general variables, the first half of general variables, is important only for the movement of the character. And this can be done in a variety of different ways. You do not have to move your character like I move my character. Kind of. We'll get to that. The important part is this event structure here. This can be however you want. I have it so if key is pressed, is up held? Yes. Is down held? Yes. Is it no? Is it no? And so when it is held, then the code will enact. So of course you can do this however you want. If your character moves around screen, you are fine. You could do it your own way. You do not have to use my code for that. But you can pause it right here and look at it and copy it all down and cheat. The important part that you will need to do the same way I do is this coordinate system right here. You could definitely do it some other ways, but we are doing it with an x-coordinate that is a set variable and a y-coordinate that is a set variable. And this is important because when you switch to a different room, your character has to move across the screen, and that we need to do by manipulating just one coordinate. And so, let's look at how that works. We come down here, we have the events, blah blah blah. This is specifically where if up is held, the y-coordinate changes, and of course based on speed as well. If down is held, the y-coordinate increases because it's going down the way SFML works. Anyway, this block of code is the movement. This is all set up here. This is what makes it happen. Player.setPosition, and then of course set the x and y to x-coordinate and y-coordinate. And then down here, player is drawn, and it's all good. But how do we switch from scene to scene? First off, we need room. If we go back up here to player control variables, we have an integer variable for room, which is either 0 or anything else, which is just going to be a 1, a 0 or a 1. And we come down here, and we have if room equals 0, that's the first room that you start in, then draw room 1. Yeah, perfect. And if it's not 0, then draw room 2. We'll show that off real quick. We have room 1. If room equals 0, draw room 1. If room equals 1, draw room 2. Right there. And so it just switches, as you can see. Room 1 and room 2 are here. They're just both in the sprite sheet, really. Room 2 is just below room 1, both set at position 0, 0. Easy peasy, lemon squeezy. Draw room 1, draw room 2. But how do we trigger those that room integer counter to change. That is this line, this chunk of code right here. If player.getGlobalBounds contains 395, that's an x coordinate, and any y coordinate, that means no matter how high or low up your player is, you can still move and jump across the screen. You could limit this if you had a doorway, only wanted them to go from one spot. But if your player hits 395 and he's in room 1, so if he hits the screen over here, then room will change and it'll switch to room 2, and then the x coordinate will change to 5, which replaces this 395, and that sends your player way back to the other side of the screen. Sorry about that. And the same thing here happens in room 2. If you are in room 2, you want to go back. So if you hit 1, or this side of the screen, it'll send you back to this side. So we'll show that off one more time, because I know it's confusing without the visual. At least it is for me. Maybe you have a stronger brain. We are in room 1 right now. If we go over here, this is where, this right here is where the x position of like 300, I think it was 395 is. If we hit that, we jump over to x position 5, and we are in room 2. We check it out. Ah, cool bookshelf. Whoa, whoa, whoa. Then we go back, and once we hit 1, of course, we're jumped back over into room 1. Easy peasy, lemon squeezy, but as you can see, the player is jumping from the right side of the screen to the left side of the screen. And so that is important to be able to change x value. Next up, we have the beautiful interactable objects. The important part for that is going to be a bool function here that we call collision, and it takes in 2 sprites, compares them, spits them back out. There's also frame right here, which is going to influence where on the sprite sheet the code looks to draw the picture, the sprite. So we have our interactable object right here, which is computer, and you've seen it on screen. And the way it works is that in room 1 the computer is drawn, but the frame of the computer, which is either 0, this top one, or 32, this bottom one, the frame of the computer is determined by this collision function. So that is down here, and it takes in object 1, which we have inputted as player, and object 2, which we have inputted as computer. And it checks object1.getGlobalBounds to see if it intersects object2.getGlobalBounds. And if it does, it returns true, and in our code, if it is true, then switch the frame to 32, which will then be referenced down here when we set the computer's texture rect, and the computer, of course, is drawn in room 1, up here with room 1. And so when we're touching the computer, the frame is equal to 32, that's 32 pixels down. Let me go full screen. And that 32 pixel down is where it says PC on it. When we walk away, it sets up to 0, which is the first computer sprite that has a blank screen. We touch PC, we leave blank. 32, 0, 32, 0. And this can be done with any sort of object. You know, I could interact with this bookshelf, make it fall over, etc., etc. And when it returns this true variable, you could have it check, you know, if collision equals true, and say the A button is pushed, then you could have clicking A on this computer mean, or you could have clicking A on this computer trigger another event to happen. Trigger, you know, a pop-up, or you click A on the computer, the lights go out. Who knows? You can do whatever you want. And because we're only drawing it in room 1, it disappears when we go into room 2, and we can't interact with it. Alright, I hope you've learned something from this video. Hope it hasn't been too long. Hope you enjoy my graphics and my little computer man here. Have a good day, night, evening, afternoon, and I'll see you next time in, like 4 months or ever? Never? Who knows? Alright, peace out.